Materials 8 is about amorphous materials. Now, an amorphous material is not a crystalline solid. It is an amorphous solid. It is not crystalline. It is amorphous. There is no regular structure. It's all jumbled up. One way of thinking about these diagrams, it's a bit like a liquid. In a liquid, there's no rows of atoms. They're all jumbled up. And this is a bit like a liquid, only the atoms aren't going anywhere. So it's like a snapshot of a liquid. It is not crystalline. It's all jumbled up. There is no regular internal structure. And amorphous solids include glass and ceramics. Glass is basically silicon dioxide, and as a chemist will tell you, that has a giant covalent structure, a giant three-dimensional covalent structure. There is no regular arrangement. It's all jumbled up all over the place. And because it's all jumbled up, that explains why glass is brittle. Because there's no regular arrangement, because there are no crystal planes, there can be no plastic deformation. So you have your elastic deformation, you have your straight line part of the graph, and then it cracks. Okay, because it is not ductile, it is not tough, because there can be no planes of atoms sliding over each other, that makes it brittle. And once you get a crack, then what happens is the stress is very much concentrated at the crack, and that crack will propagate very, very quickly through the material, and it will fail. Okay, ceramics are brittle as well, but they have other desirable properties. For example, as insulators. This is the old space shuttle coming into land, and its tiles underneath were made of ceramics because they're very, very light and strong, and very, very good insulators, thermal insulators.